Okay, today what we are going to cover is we are going to look at equations that are going to involve some percents. We want to know what does a percent mean and how can we use that in calculations. Percents are pretty important to us because that's how they show discounts at stores or anything like that, savings that you are going to get. You get a certain percentage off. The next thing that we are going to look at is just some equations from geometry. So as you are aware by now, you've been in Saxon forever, is that they intermix the geometry and algebra together. So next year it might be called geometry, but it's also been called an Algebra 3 class, just because of the intermixing that Saxon does between geometry and algebra. Okay, so if we look at the first thing, percent problems, what does the word percent mean? Part of something, a part of how much? 100. Cent is a prefix, so you talk about centimeters, you talk about a century, you talk about cents in a dollar, and it always makes reference to 100. So the word, just like the word of means multiply, the word per means divide, and then we have cent, so divide by 100. So it tells us that 18 is 20% of what number? Now we could set this up as an equation because we have the word 18. So we could start off with 18. Then you have the word is, which means equals. And then we have 20%, which I could show as 20 over 100. What does the word of mean? Multiply. So it's 20 over 100 times what number? X. So I have an equation set up. 18 is means equal to, 20% means 20 over 100, the word of means times, and then what number? So we have our equation. It says work the problem and then draw the completed diagram. We want a diagram for this. So as I look at this, I could solve. We could reduce, what's 20 over 100 reduced down into? 1/5. So I have 1/5 x. How do you solve that equation? Divide by 1/5, which means the same thing as multiply by 5. So I'm going to take 18 times 5, and we get an answer of 90. So 20% of 90 is 18. Now I have to make a diagram of it. What does this whole diagram mean? Sometimes I find it easier to work with a box diagram. If I were to solve this problem another way, I could set it up as a box diagram where one of them deals with my percents, one column. One column deals with my percents, and the other one is the actual number. So if I look at this, it says 18 is, when we set up our boxes, we can always think of is over of, because that's what we did over here. 18 represented, it came right with the word is, 18 is, and then I have this 20%, and then I have this of what number. So when we set up a box diagram, we could look at the boxes as the percent over 100 is equal to is over of. That's a key thing to know. So if I set it up, I go back up to what I have boxed in green in the equation, and I can set up this problem quite easily, and then it's just a cross multiply and divide problem, whereas I read it, it says 18 is, so that goes in my is box, 20%, so there's my percent, this is always going to be 100 right there, and then it says of what number, so my of box is what I'm looking for. That's my what number. How do I solve? I cross multiply 100 times 18 and divide. Whoops, I was thinking what the answer is. And divide. So I divide by 20, cross multiply and divide. And when you do that, 20 goes into 100 how many times? 5, which is what I was thinking as I wrote 5 in the denominator. So I take 18 times 5 and I get 90. So that what number becomes 90. Now your percentage goes straight across with your amount. So if I had 100%, think of this as a sale. If I had 100%, how much would I have to pay? $90. If I got a 20% discount, how much did I save? $18. How much do you pay? You pay 80% of it, which is how much money? Check your math. What would I do? If I save $18 and the total amount is $90, I would pay $72. This is as a diagram. This includes all your information right here, and I would accept that as a diagram. I circled that bottom calculation part, but you don't need to. But there's your diagram. You come back over here to the red calculation as we set it up as an equation. For some of you, you think equation-wise. And if you set it up into an equation, we still need a diagram. The diagram they are making reference to is a bubble diagram now. If it were 100%, how much would that be? 90. In terms of money, it would be $90 for whatever I am buying. But if I break it into two parts, I still have my whole circle, so it's still making reference to that 90. They tell you, the book tells you your diagram would be 20% is how much? 18. But then you got to finish the diagram and say 80% is how much? 72. Now, which diagram do you like better? The bubbles? Or can you make sense of this one where you just go straight across, the percentages in one column and the amount in the other? Who prefers the green? Show of hands. Sweet. So it's okay if I work through the green way? You have to remember this information right here, though. This is a key thing. Know that setup right there. Percent over 100 equals is over of, and then you can just erase and start to fill in based off of your sentence. Percent over 100 and is over of. Can you repeat that? Percent over 100 is over of. Percent over 100 is over of. Percent over 100 is over of. They're just percent problems. That's probably what I would call them. If you're making a label in your notes. Percent over 100 and is over of. Can I change the slide now? All right. So we look at another one. This one might end up just a little bit different in the diagram, but I'll make note of that because I wanted to provide you with another example. If I go through and read through the problem, we're going to stop. I had three key words, percent, is, and of, right? So I read through, and I'm just going to stop once I get to one of those words. 1,500 is what percent of 250? Can you put that in that box diagram? I have it highlighted for us. If we look at the box diagram, should have made it wider instead of taller. Percent over 100 is over of. That first part, 1,500 is, where does that go? In the is box, of course. So we have 1,500. Then I have what percent? Where does that go? Percent. So I'm going to take this out, and I am going to put X, because it says what percent? Of 250. So that goes in the of, so I'm going to eliminate the of and put in the value of 250. What do we do? Cross multiply and divide. Now, one thing before we do that, my question for you is if you come back to this diagram, you should notice that where is your largest percentage in this box ratio over here? 100. If this is your largest value, what do you think your largest amount is over on the right-hand side column? The bottom one. Where's your smallest percentage? 20. Which one of the values on the right-hand side is your smallest value? Right with the 20. And this is the middle, 80% is in the middle of the two numbers, so the same thing's going to happen over on the right-hand side. Those numbers should correspond to each other. So if we come back to this problem, what do you think is happening? Compare 250 to 1500. 250 is my smaller number, 1500 is my larger number, so what do you know about your percent in this case? It's going to be greater than 100%, which is going to be if you got a pay raise, something like that, that's where you would get greater than 100%. Maybe your paycheck now is 150% of what it used to be if the original was 100%. So we're going to cross multiply and divide this. I take 100 times 1500 and divide by 250. How would you go about calculating that? Would some of you go ahead and multiply and then do a long division? Can I show you some methods of canceling that might make it easier? You know how many quarters are in a dollar, right? Yeah, that's pretty easy. Let's get rid, and some of you might want to get rid of a 0 with 100 and 250. But what happens if I just get rid of this 0 right here? That 0 drops off, and now you have this value of 25, and it goes into 100 how many times? 4. So I can get rid of 25 and go into 100 4 times. So now how do you solve your problem? 150 times 4. That made it an easy calculation, right? So I'm going to take 150 times 4, and what's your answer? 600. I increased it by a lot. %600. Now what about my diagram? Do I have to fill in that top box? You do not have to fill in the top box if your percentage is greater than 100%. And here's why. Because if I looked at the bubble diagrams that they talked about before, you always start with this 100%. What is 100%? 250. Then what happens to that? My 100% gets bigger. It gets bigger. I don't have two small regions. I have one big region where 600% is 1500. So since that percentage is larger, I don't have to worry about filling in this top box in the box diagram, and this would work for your diagram. But see the difference between the two. Okay, I am going to give you 30 seconds to describe the difference between a diagram that has the 3 boxes versus a diagram that has the 2 boxes. Go.